Probability in poker using the binomial coefficient. In this video you will learn what the binomial coefficient is and how to calculate probabilities with it, using examples from blackjack and poker. Given a set of size n, the number of ways to choose r elements, where the order doesn't matter, is equal to the binomial coefficient. This can be determined by this formula. Note that there is only one way of choosing no elements, or n elements, from a set of size n. So n choose 0 and n choose n are both 1. For small values of n, you can also use Pascal's triangle. This is a triangular array of numbers where the values at the start and end of each row are 1s. These represent n choose 0 and n choose n, and the rest of the numbers are the sum of the two numbers above it. So this number, in row n equals 2, is 1 add 1, which is 2. These two numbers in row n equals 3 are both 1 add 2, which is 3. These numbers are 4, 6 and 4, and these are 5, 10, 10, 5 and so on. Just keep going for as many rows as you need. So if you wanted to work out 4 choose 2, you go to the nth row and count across from 0 until you get to 2. So 4 choose 2 is 6. Note that Pascal's triangle is symmetrical because n choose r is always equal to n choose n minus r. Let's start with a simple blackjack example and work out how many different combinations of two cards there are that you could be dealt at the start of a game of blackjack. Well, there's a deck of 52 cards and we're choosing 2 of these, and the order is irrelevant, so we can use the binomial coefficient, getting an answer of 52 choose 2, which is 1326. We can also use this to calculate how many ways there are of getting blackjack. This means getting an ace and a card of value 10. There are 4 aces, so 4 choose 1 ways of getting 1 ace. There are 16 cards valued 10, so there are 16 choose 1 ways of getting one of these cards. Multiplying these together gives all the possible combinations of these. This is equal to 4 times 16, which is 64. We can also use the binomial coefficient to work out certain probabilities. If all outcomes are equally likely, then the probability of an event E occurring is equal to the number of outcomes where E occurs, divided by the total number of possible outcomes. Assuming the deck is properly shuffled, all cards are equally likely to be drawn. Since there are 64 ways of getting blackjack and 1326 possible 2-card hands, the probability of getting blackjack is 64 over 1326, or 4.8%. Let's do another blackjack example. This player, player A, has been dealt a hand of value 11. The player on the far side, player B, has a jack and a queen, and the dealer has a king face up. At this point, it is impossible for player A to go bust, so he hits. He has been dealt an 8, so now he has 19. Now, what is the probability he would go bust if he hits again? Well, player A would go bust if he received any card of the 44 cards from 3 through till king. 5 of these are already on the table, so there are 44 minus 5, which is 39 such cards that he could be dealt. There is a total of 46 unrevealed cards, so the probability that he goes bust is 39 choose 1 divided by 46 choose 1, which is 85.4%. This is quite high, so he decides to stick. Now let's look at 5-card poker hands. They are ranked in this order, with a royal flush as the best hand, then a straight flush, all the way down to a high card at the end. In this game of 5-card draw, player A has been dealt a 2 pair. What's the probability of this happening? Well, this is the same as choosing 2 from the 13 different ranks of card, then choosing 2 of the 4 suits for each of the 2 cards, then choosing 1 of the 11 remaining ranks for the spare card, and then choosing a suit for this. Then divide this all by 52 choose 5 to get a probability of 4.8%. Now let's look at player B's hand. He has been dealt a pair. What's the probability of this happening? The number of ways to get a pair is found by choosing 1 of the 13 ranks, choosing a suit for both of them, that's your pair, and then choosing 3 of the remaining 12 ranks and choosing a suit for each of these. Then divide this all by 52 choose 5 to get a probability of 42.3%. Now let's look at the swap. If player A swaps out his 4 and draws a new card, what is the probability he gets a full house? He will get a full house if he draws an 8 or a 10. Since there are 2 8s and 1 10 left in the deck, there are 3 choose 1 ways of this happening. There are 42 cards left, so the probability is 3 over 42, which is 7.1%. If player B swaps out his 10, 3 and 2, what's the probability he gets a 4 of a kind? He will get a 4 of a kind if he draws both of the remaining 2 5s and one of the 39 remaining cards that aren't a 5, so there are 39 ways of this happening. Since there are 41 choose 3 total ways to choose 3 of the remaining cards, the probability is 0.4%. Now let's look at a Texas Hold'em example. Player A has been dealt pocket aces, and player B has been dealt an ace and a 7. The flop is an ace, a 2 and a 7, so now player A is winning with 3 of a kind, and player B has a 2 pair. Let's work out the probability that player B ends up winning. The only way player B can win is if one of the 2 remaining 7s is dealt, which would give him a full house. There are 2 choices for the 7 and 44 choices for the remaining card, so there are 88 ways this could happen. Since we're choosing 2 cards from the remaining 45, the probability is 8.9%. Let's look at another example. Player A has been dealt a 6 and a 5, and player B has been dealt pocket 6s. The flop is a 6, a 3 and a 4, so now player B is winning with 3 of a kind, and player A has a pair. Let's work out the probability that player A ends up winning. The only way player A can win is if one of the 4 remaining 7s is dealt, which would give him a straight. There are 4 choices for the 7 and 44 choices for the remaining card, so there are 176 ways this could happen. Since we are choosing 2 cards from the remaining 45, the probability is 17.8%. What are the chances? Well, we hope you have enjoyed the video and that you've learnt something about the binomial coefficient and probability. Thanks for watching.